Hello, and welcome to the Fundamental Theorem of Calculus presented by www.free-academy.com. If you watched the introduction to the definite integral lecture, this equation right here would look familiar to you. And this is the first part of the Fundamental Theorem of Calculus. I covered it before, but for those who haven't seen it or are just checking in now, I'm going to redo this part, basically. If you did watch the previous one, you've seen this already, just skip to the part 2. Alright, so the fundamental theorem of calculus states that if you take the definite integral from a to b of little f of x dx, that will equal capital F of b minus capital F of a. And remember that capital F of x is a notation for the integral of little f of x dx. So really what this is saying is that if you have a curve from A to B and you take the integral of that curve, the point that you evaluate at B, subtracted minus the point that you would evaluate at f of A, is going to give you the area underneath the curve. Now this may not look like a lot of sense on the graph that I gave you here, but let's take a look at a really good example where f of x equals x, in which case your integral of f of x is going to equal 1/2 squared, or it's going to equal 1/2 x squared. So in this case, you would be taking the two different points on the actual integral equation. So that's where the fundamental theorem of calculus came from. Just to be thorough, we do a little notation in the intermediary step of f of x a to b, or you could just draw that with a straight line too. That exactly means the statement that we have capital F of b minus f of a. So that's part 1. On to part 2. Part 2 of the fundamental theorem of calculus states that if you take the derivative of the definite integral from a to x of f of t dt, that will equal f of x. Basically what this statement is that if you take the derivative of the integral, you get the original equation back. What the difference is between that, and the fundamental theorem is that you can take it from any point on a to b, on a to x, and it'll still equal the same. Now let's take a look at our actual integral from a to x of f of t dt. When we evaluate that, we're going to get f of x, capital F of x, minus capital F of a. Now if we take the derivative, let me switch the color here. If we take the derivative of both sides, then we're going to get the derivative of capital F of x minus the derivative of capital F of a. Well, we know that the derivative of capital F of x is going to equal little f of x, and f of a is a constant. So the derivative of that is going to equal 0. So that's the quick and easy derivation of the second part of the fundamental theorem of calculus, or the proof I should say. There is actually a more rigorous proof, but I cannot think for the life of me why you would need to know it, so unless somebody asks me to go through the rigorous proof, I'm not going to. So that's the fundamental theorem of calculus. Enjoy.